Good morning to everybody and good morning to the Esade podcast. Today we have with us Dr. Stephen Willmott. Stephen Willmott is a mathematician, turned computer science first an entrepreneur later, and now it's a senior director and head of the API infrastructure at Red Hat. Dr. Steve Willmott served as a professor at the UPC for many years and was the one who was directing quite a lot of European projects, mostly on AI and agents, all this kind of stuff. Then he created Freescale, that was a company with office both in San Francisco and Barcelona. And rapidly, Freescale became a leader in API intermediation in the world. API intermediation takes of a very simple problem. I mean, how do we manage all these hundreds and hundreds of thousands and hundreds of thousands of millions of APIs around with so many companies, and how we make them pay, and all these payments we make them sensible and easy for companies. So this was a solution that was very much seek for many companies, and that opened at that time API interfaces. This was a very welcome solution, and of course it was lots of growth. After quite a lot of years in the market, Red Hat bought Freescale, and then Red Hat was bought by IBM. This is normal, it's part of the consolidation and transformation in the sector. It happened to all of us. I mean, I don't think that any of us work in our original companies. They are both disappear, diet, or whatever. And this characterizes the sector. In addition to that, Dr. Stephen Willmott also has a passion for games. And maybe we have a small part to talk about it. Dr. Willmott, it's a pleasure and an honor to have you here. We are so happy to have you.
Thank you. It's a pleasure to be here. Thank you for the invitation. I really appreciate it.
Thank you so much. So let's start with this podcast. I mean, probably everything started around 2012. In 2012, Jeff Bezos wrote this very famous memo on the API mandate, transforming the whole structure of Amazon from becoming a monolithic company in terms of IT to becoming an API company. This made great gains for Amazon. This made for Amazon easy to open the boundaries to third parties in logistics, in the marketplace, and so on. Now it's not 2002, almost 20 years later. What are the APIs today?
Good question. Yes, I think Jeff Bezos's email to the company in early 2000s is a really great read if you've never read it, because you'd think it was technical, but it's not technical. It's actually organizational. It just says you should connect to all other business units in a structured way using APIs. And that's the way to do it. Don't make direct connections with unstructured technologies or just straight to the database or whatever. So he didn't even specify what type of API to use. He just said, be deliberate and structured about the connections. And that's a lesson that I think Amazon learned, and they evolved many, many times, but the organizational structure created their ability to connect to many other companies. And there were some public APIs at the time. I think eBay had an API in the early 2000s. There were a couple of others that came out, but it took still a long time for public APIs to become real. But Amazon had already organized internally, and a few other companies had. Today, it's really common for companies to have APIs. In fact, if I look at the Fortune 2000 that we work with, almost everybody has APIs in many places of the business. It's not always so consolidated. It's not always so deliberate, but it's clear that our IT systems have become hundreds of times more complex than they were in the early 2000s. And these connections are really critical. And I would say many things about people doing it well or not doing it well, but APIs are clearly the kind of the glue that's holding many IT systems together today.
Many things are changing, as you said, in computer architecture in companies. The monolithic application is definitely rich. Private data centers are being replaced by cloud or hybrid clouds. The modern system design is based on microservices and data streams. A good example could be in the AWS world, AWS Lambda and Kinesis. And microservices express themselves, connect through APIs. Was all this free scale too early, or was a part of a slow evolution that takes quite a long time to happen? Is today when we're seeing the real API transformation, or is not even today? It would be tomorrow. What do you think?
I think there are many phases, right? So there's still some very big phases which we've hardly started. For sure, in 2007, 2008, when with Rescale, it was pretty early. So most people did not know what an API was when we talked to them. So people were really not familiar with that technology. They had heard of web services and SOAP and XML and some other technologies which did similar things, but it was rare that people knew what an API was. So to some extent, the 10 years after that was building the usage of APIs in a very high growth way, but still, it was still only touching a few companies. And now we see it in almost every company. So there's been a big transformation. I'll talk about microservices in a minute, but APIs have really grown and they've become much more mature now. So they're a very mature enterprise technology now. The phase that I think is still to come, which is the one we thought was almost most exciting in 2008, which has still not come, which I believe is when essentially every company has all of its major functions exposed as APIs to the public internet. And that's still not true today. Most companies do not have that. They're closed partner systems or they're very limited functions and so on. But when all major functions are there, you can imagine that the internet becomes a much more rich toolbox than it is today. Websites essentially mean humans click on lots of buttons to do things, but why would you need that if you were able to automate that? And I believe it will happen because we have now things like Amazon Alexa and other devices that are voice activated. Keyboards are disappearing. There are many reasons why the standard website is probably going to need to be replaced by many other interface types. So I think this whole world is still very, very nascent. I think the API evolution is still, let's say, in the middle.
That's great. It's true. We all were dreaming of agents doing many things on behalf of us, and we are still clicking too many buttons everywhere all day long that we don't know what on earth they do most of the time, and so on, and erasing too many emails that we subscribe one day, and so on, which is,
and accepting too many cookies.
yeah, accepting too many quickies that we don't even read, never ever. So yeah, that's absolutely it. And so this is very linked maybe to the computer architecture that evolved tremendously. And now it became software. Now all this power part and so on, it's configured through software. You go to a website like Amazon and so on, and then you configure the computer that you want, or you can do it programmatically with Python or any other thing. Not only that, I mean, databases that we were all fighting with, now they have a single-digit millisecond performance and infinite scalability like DynamoDB or Cassandra or many other databases that you have in the market. However, this stream of microservices that are behind the APIs still have a significant latency, and still are driven by language that are interpreted like Python and so on, which have this a little bit core star problem and have this modern languages didn't solve that. If you go to Julia, it's the same thing or worse. And it seems that we are catching this kind of problems. Do you think that this dream of getting rid of the computer architecture whatsoever and having functions in the cloud will ever be true? Because now we have these Lambda functions and so on, but they are full of restrictions, full of things that you cannot do, full of complicated stuff. And then many times at the end, you put a virtual machine and a virtual computer doing the other stuff because it works. And the other, well, not so clear how well it works. It's true that things are evolving. But this stream of microservices that we need for these agents that click instead of us will ever become true?
So I do think the technology is getting better all the time. I mean, I'm shocked at what's possible today compared to 5 or 10 years ago. And I do think microservices architectures are very powerful. The main thing is it's not a solution for everything, right? Like anything is not, it suits certain scenarios very well. Microservices scenarios are great for certain things, and they're bad for others. And if you listen to technologists over the years, then let's imagine around 2000, the message is decentralized, decentralized, decentralized. That was the web services message. Yeah. Then a few years later, it was like, well, this is a lot of complexity now because it's really complicated when you have all these small pieces everywhere. So the message was centralized, centralized, centralized. And you got ESBs and enterprise integration buses and central registries and all these things. And then the next cycle was, well, decentralized, 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 right? So now we're in the microservices world. And I think on each cycle, we get a bit better, but we don't solve all the problems. So an analogy would be if you're going to go on a long journey, you know, with 25 people, the question is, do you take a bus or do you take 25 motorbikes, right? And I know what your answer would be. But the point is, you know, it depends. It depends. If you're going on motorways to Germany, then the bus is probably a great idea. If you're crossing the Sahara Desert, I pick the motorbikes, right? So microservices is like that. It's an architecture that only applies to certain cases. And in other cases, centralized is still better. And you mentioned latency problems, right? We see a lot of customers that push to microservices very fast, and then they find they have a lot of complexity in between the microservices. They have to manage this latency and all these things. And often for some applications, it's better just to stay, you know, in a certain set of containers managed very tightly with a tightly coupled architecture for those executions. That's better if you know how big you have to scale that component and you design it in a very, very high performance way. But if you don't know how many new things you need to add to it or how much capacity, then microservices is a great idea, right? So you have this trade-off going on, and the technologies are getting faster all the time. So I think the latencies will go down. What will not go away is the inherent systems complexity of distributed systems, right? The idea that microservices remove complexity is a false one, because it just moves the complexities from inside the services to between the services. So you have to be ready for this. That's the real thing to remember, I think.
Mm-hmm. You mentioned containers, and I'm very curious about your point of view. In the last 5-10 years, the world has been taken over by Kubernetes, and then the fast responses of the big players, and AWS came very fast with CCS and Fargate, and nobody knew what you can do with CCS and Fargate, and nobody wanted even to try because it was so new, breaking all day long. And then finally, the whole thing has been fixed somehow. But now it's as you say, the pendulum is swinging a lot between this monolithic application to microservices. Microservices didn't work so well. Then we went to containers. Then we try to go to microservice again. How do you see the future of containers? And the Kubernetes world, the CS world, and so on, here to stay, or it's just an interim solution that we don't know?
I think containers are probably fundamentally more important right now than, they're at a different level from microservices and function as a service and serverless, right? I think fundamentally, if you look at what's driving IT today, containers are just critical, and they will continue to be critical for many years, 5 to 10 years at least. And the reason is that they provide this level of abstraction to hardware that VMs provided before, but they provide it in a much faster, more portable way. And so even if you look at Red Hat's strategy, Red Hat really is focused on hybrid cloud, which means run your workloads anywhere on any of the major clouds or on premises. And what containers allow someone to do is whatever architecture they're running, even if it's monolithic or if it's microservices, whatever, you can spin these containers up and create copies of all of these systems all over your entire IT landscape. And that's, if you look at the major reasons why IBM acquired Red Hat, Kubernetes and containers is really front and center to build these hybrid cloud systems. Now, I don't think containers preclude function as a service or microservices. In fact, Red Hat's function as a service solutions are based on containers, right? At some point, you know, the dirty secret behind serverless is that there are some servers, right? Someone is managing the servers somehow. And right now, the way to do that is using containers, actually, funnily enough, right? So I think these technologies layer on top of each other. And containers are a great abstraction because they finally kind of nailed relatively fast startup portability with security for workloads, which VMs had the security and kind of the safety, but they didn't have this fast startup portability. So I think containers will be with us for a long time, and they'll be a fundamental building block. But the other things, microservices and functions, will be there on top and evolving very fast. So one day the containers will be there, but you will not know they're there anymore. So yeah, that's the way it will go, I think.
Yeah, that's a great idea. I think that the containers will be completely transparent to the user and will be the implementation of functions probably at the point. And now solve these major problems that you have with functions like Lambda and so on. That is the cold start problem, that is the responsiveness, that is the lack of resources, that is the lack of orchestration capacity across things that are a little bit more complex that just running Python and all these kind of things. It's fantastic. Let's go to the other side. In parallel with this technological development that has been extremely fast, and we observe, maybe with astonishment, that when you go to the management community, we don't have this kind of understanding and this kind of development. Companies, large and small, many times are absent of this transformation and all these discussions that we have to go to containers now and so on. And that should be the core of the company, because the benefits in terms of scalability, in terms of marginal zero cost and so on, are so great in terms of agility that now with the COVID has been so important. It's so clear, but few companies size these benefits. Most of the companies are completely absent of all these discussions, or most of it absent. They're still with data centers, or they're still thinking, do I go to the cloud or not? They didn't face the hybrid cloud. They still are into things like, why this happens?
Well, firstly, I think I would challenge a little bit that most are absent, right? I spend a lot of time with customers working on architectures and all sectors, from finance to telco to media. There are groups in each of these customers working on these transformations, and some of them are very advanced, some of them are not. There's definitely areas where people are behind, and obviously some companies are further ahead than others. I would say that there are two factors which make it harder for especially large companies to transform at this level. The first one is that the legacy systems, people obviously want to modernize, right? But the investment in legacy systems is massive. And in many times, they perform hugely mission critical systems. And in many cases, for many companies, these systems were built at a time to last for a while, and the people that built them are no longer there. Which means you have lots and lots of systems which have been invested in over 20 or 30 years that if they went away suddenly or were transformed, this is an extra cost the company simply had not planned for in any way. The good news is that very often you can wrap these components in APIs and bring them into a more modern world where you can do your new development that still uses the old components. So I think it's very unlikely we'll see completely transformed companies from an IT level that literally replace every single system they ever built. In fact, that would be economically suicidal. I think what we're seeing much more is people putting an API / microservices / cloud architecture on top of their existing systems. They will very, very often keep their on-premises data centers, especially now with COVID. They want to get the maximum out of the resources they already invested, right? But I think they will add different clouds. They will add new capabilities on top, and they will add APIs to connect these systems together. So that's really, the first thing is this, we cannot just throw the legacy away, right? It doesn't exist. And coupled with that, most large companies want to use multiple clouds. They want to use Google and Azure and Amazon. And so this really is important because it's not just lifting and shifting everything to one place. The second reason, right, which is a bit more amusing, I think, is that most of the technology companies, and I would include Red Hat and IBM to some extent in this, IBM less so because they're better at it than we are, but many of the technology companies are still not good at explaining how their technologies solve real business problems, right? We are still showing them that one flavor of Kubernetes is better than the other flavor of Kubernetes, but we don't explain why you need Kubernetes in the first place, right? So this is a very significant problem. And I think the transformation benefits only come if you actually show how teams can reorganize, how data flows can be better, how new functionality is being created by the customer. So one of the most exciting things that I've seen in the last couple of years are, many companies do this, but Red Hat does it really quite well, are these things called innovation labs, where customer IT teams come and work directly with specialists on all sorts of technologies, and they just build something for a few weeks. And normally these result in really great ideas on how to transform. Most of the time, the marketing of the IT companies just isn't good enough to explain why you should be using these technologies, to be honest.
Mm-hmm. Yeah, and that's absolutely true. I think in business school it's the same thing. Many times we see technology as a performance enhancement function, and that's it. Many times as the very simple models of growth in economics. See technology here, new technology comes, and then you raise productivity, but not as a transformational agent, not as an agent that will transform internally the company, doing things completely different in a completely different way. So people say, okay, it's a performance enhancing function. You mean 10% better, and I have to invest a lot, and who cares? Well, and they miss the whole point, because it's not 10% better, and then who cares? It's your company is going to change, and if not change, your company will be dead, and then you will care, which is a completely different. And we are very bad to transmitting this idea of why one thing is important or it's more important than the other. One thing that is very interesting is APIs always talk about the external world, how companies communicate with the exterior and so on. But also API change a lot how companies are organized internally. And you have been participating in many of these transformations in companies that are small or big. What can you tell us about all this?
Yeah, I think right now, at least today, is the biggest value that's kind of unseen with APIs is often internal. They make possible reuse of things that were just not reusable before. In previous generations of technologies, web services and so on, you would create point-to-point connections. And every time a new business unit wanted to connect to you, you'd have to create another one, which created not only cost, it created new legacy every time. But this generation of APIs is much better, and typically you would create one set of APIs for your business unit, and then other people can use it in multiple ways, and it will just evolve slowly over time, but you're serving many needs with the same interface. And some of the funniest things I've seen, I mean, I won't name the banks, but there are a couple of banks that we worked with, and they had many APIs, but they had servers where calls were coming in, they had no idea where the calls would come from, right? They just literally didn't know. And in the end, sometimes the only way to check was to switch off the server and see what happens. This kind of crazy transformation. And in many cases, companies have no idea what APIs they have. And when they do the inventory and we help them, they find 3 or 4 APIs that do the same thing from different groups, sometimes even using the same data. So there will be maybe you have a database, another team is copying the database onto an FTP server, unpacking it, creating a new database, reformatting it, and creating an API for that, because they don't know that you have your own API. So you have these crazy scenarios within companies where over years, there are data flows which have never been audited, never been checked. And so there's huge potential in making all this much leaner. And it's like you say, if your industry changes suddenly and you need to transform and produce a new set of functions for your customers, and you don't understand your own data infrastructure, you're dead, because you cannot move. So you need to do this internal transformation to actually be ready to respond to change.
Can you give us some clues about this internal transformation? How would you start?
What I've seen successful is there must be a set of use cases that are business focused, right? If it's just the IT organization saying, okay, it's time for us to invest in our infrastructure, and they try to do a project to clean stuff up, maybe they even get budget. But the danger is that over time, this budget is seen as things to be taken away when there are other emergencies. It's really important to build a partnership to say, we are going to build some new capabilities and we're going to wrap some old ones. And we're going to work with these 2 or 3 business units. This is really the only way. You have to connect to some key business. And this sounds really obvious, but many people don't do that. And the other reason is that helps you get the right infrastructure, right? Because if you just imagine the IT team inventing, well, they say, we want to go to Kubernetes and containers and we want to do serverless. So let's do it, right? That always ends badly because there are 10 million ways to do this. And why would they pick one that's going to work, right? So I think it's this driving to some new business outcomes and attaching the transformation project to those business outcomes is a really critical step.
That's great, fantastic. Let's change gears and then let's go to the open source. You have been working in open source for many years. I mean, the open source started as a movement that was kind of revolutionary. We're going to change IP, we're going to change the way software was built and so on. That has been so successful, particularly in system software. And after that, big companies came, but big companies sized this open source movement and so on. And now it's a completely different picture than the one that was before, particularly for the big programs. But do you see that there's still room for individuals, small companies, even the public sector to do things in open source? Or is just the way that big companies have to produce big software projects?
I think there's still huge potential and frankly need for open source in many ways, right? So in fact, I distinguish 3 things. There are open standards, there's open source, and there are open interfaces. And you really need all 3 of them. Like if you don't have standards which emerge, then it's hard to keep all the interfaces working. If you don't have open source implementations of the standards and the APIs, then often an industry cannot get off the ground and getting connected. So I think open source is critical. Obviously Red Hat, every single product that Red Hat makes is open source first. So all the code, Red Hat's model is to make all the code open. There are other companies that do other models, which are fine also. You know, they have some of the code open and so on. I wish all those companies well, because I think that the shared code is so critical for us to build our systems safely that we would all be very lost without it. And it's going up the stack, right? More and more systems are becoming open source. I would point to one thing that's worrying about open source right now for companies, which is that there are some licensing challenges sometimes when open source projects that are popular get taken by companies and run as hosted cloud services. Some of those companies don't always give back the innovation that they have created. And so they monetize the open source without giving back to the community. And this is a little bit dangerous. Well, it's quite dangerous, actually. So you've seen some changes in open source licenses from companies like Redis and so on, which I think rightly have defended themselves against other companies using their software to run a hosted service to compete with them, but not give back any innovation. I think there's a huge future for open source, and I'm grateful to all the companies, including Red Hat, but also especially Google, Microsoft, actually, many companies that give back very freely to open source, because I think that the cumulative benefit to the world is just huge. If we didn't have open source, I think, you know, we could probably roll back at least 10, 15 years of innovation in IT right now, which would take us back to 2005. And, you know, there was no iPhone in 2005. There was, you can imagine that, right?
Yeah. Yeah, in fact, open source changed a lot. And now many of the products that we use are open source, particularly in system software, things like React, Angular, even what we were talking before about Kubernetes, things like Fargate of AWS have an origin in open source, so there's refactor open source. And other kind of things. I mean, the most common databases that that you have in the AWS system are versions of open source databases. So they are thinking many things. Also, things that were unexpected, like low-level instruction sets. Now we have low-level instruction sets, and now that probably the kingdom of the 8086 instruction set is diminishing and starting a new era of processors and coprocessors and deep learning processors or neural processors and so on. All this is open source. So how do you see the future of open source?
Well, I think that it is more and more challenging for a small company to take a fully open source product from the beginning and build a sizable enough cash flow and so on from an open source product to succeed in the market. This has happened a few times in the past few years. The companies that have gone public with open source offerings, right? Probably 10, 15 of them. It's getting harder to climb that mountain because there are now many players that will suddenly pop up and support things. So maybe the customers will not buy your support, and it's challenging. So I hope that what will continue to happen is that large and small companies will continue to invest in open source, not just if they're building it, but also in the foundations that help guide the specifications. I think it's a bigger mountain to climb now, and many companies are investing. They're sponsoring projects. People are using things like Patreon, for example, to sponsor open source projects. And there are even some open source specific funding options and things like that, which open source projects can get off the ground. So it's crowdfunding for open source, really. And I think that's really exciting. I think people are willing to contribute, but they need to find a way. And sometimes they cannot contribute by writing code. They can contribute by helping with marketing or by donating money or whatever it is. But I think we all need to keep investing in those things, and that will keep the technology more democratic. I think that's the key thing.
Pattern is fantastic, but on the other side, you see that the traditional model of open source is being eroded. The traditional model of I provide you, like Red Hat, I provide you security by having a verified and tested version of Linux that you can run in your system and so on, is being eroded in the sense that, well, you have companies that do cloud that provide the same thing for free. Because you pay per use and you don't pay for the software, the testing, the validation, and so on. All this is included in the usage of the content. And many things have been moving to the cloud. So how do you see the business models that could still work in the open source community?
Well, I think the business models are evolving. So Red Hat, for example, now provides managed versions of most of its products, and it's aggressively pushing that way. So you can get hosted OpenShift, which is Red Hat's Kubernetes, on demand. So companies like Red Hat that traditionally did soft packaged software, they are moving into hosted. There are other companies that don't do the software and just do the hosting. Some of them behave really well in the sense that they contribute back to the original open source community. For me, the key question is, are you contributing back to the open source? Not your business model. So the companies that contribute back are helping the ecosystem, because then more people can support these services hosted, or customers can run them on premises. It's when people only take the innovation and then monetize it for themselves that gets dangerous, because sometimes they become so dominant that no one else can make any money. And so I think there are some license changes which are making it more difficult for people to do this, to just take and not give. But I think open source will survive easily the cloud era. I do think that cloud and open source are very compatible, as long as the people hosting the cloud services are also contributing back to the open source.
On the side of this tension, or besides this tension, we have another one that is East and West, basically China and the US ecosystem that compares the US, Europe, Israel, and some other countries. In this, you see the tension of, well, on one side, copying many things, on the other side, attention making, trying to make proprietary some other things to avoid this copying and to avoid the lead. But on the side of China, for example, having much more data, captive market, and the possibility to raise money so easily from the government and to have initial level of money. And then in the middle of all that, you have the old organizations like Apache, NumFocus, and so on, trying to survive all this mess of huge players and so on. Do you still have a chance?
I think they do. I think, especially because they are non-political in general. I mean, when they get large, then large companies become involved. So there can be a lot of politics in this sense, right? Which is sometimes damaging. But I feel that they are non-geopolitical, right? So in general, they have a more neutral role in the world. Some of them are maybe very US-centric, so it's not completely true. But I think that creating technology that is reusable by anyone in any geography is quite important, because this it basically means that we're able to push the rate of innovation to places on the planet that maybe hasn't seen the same rate, and the baseline is moved for everybody. So I'm quite optimistic because I see more and more investments in these open source foundations. In some ways, it would be nice if there were more of them, because we seem to have gotten a little bit ossified in the options. So, you know, having a bit more diversity in the organizations themselves might help as well. But I think that is a good place to invest. And my experience has always been that they're very, very smart people that contribute to the projects there. And in general, they're focused on getting the technology right and making it work well. And they're less focused on the politics of it, which I think is good.
That's fantastic. One foundation that we need is one for the public sector. The public sector there is a huge need of open source in the public sector. When you look at IT in the public sector, it's like going back to the 80s. It's terrible. We need a foundation in the public sector. That's obvious. Going on another side, we have been talking about system tools, open source, and so on. But now the discussion is on AI. And in AI, we are seeing also different forces. And now it's a force that is moving AI to metal, to hardware. That is moving to AI to silicon. The inference engine, for example, in AWS and so on, they are diminishing the cost of AI in a way that we never thought it was possible before, particularly for deep learning, but also for other kinds of AI, like singular SBCs or matrix transformation, or all these other kinds that are easily to package as a model and to put into an engine like that. How do you see the future of AI and open source?
This is I don't really know whether to be optimistic or pessimistic about this, right? On the one hand, there are a lot of open API of open source AI tools, so some great ones that have been released, and that's been a really big thing and important. But I think one of the lessons of the last 5 years is that the tools are one thing, but the data is a totally other thing. And you know, the companies that have the biggest leads in certain parts of APIs because of AI is that they have the data available, and I don't really see that changing in a very rapid way. I'm optimistic in the sense that I think there will continue to be open tools. I'm hopeful that some of the data will be made available in forms that people can innovate with it and create new AI systems. But I'm worried that if that doesn't happen, we will end up with only a very few players that are really able to do AI at a very significant level. And I think that will be a problem because, again, you'll have this bootstrap problem that no one will be able to get enough data in one place to actually do something meaningful. And that might seem beneficial for the big players for a while, and probably will be, but it will cut innovation in the long run. I think the ethics problem will grow. If we have AI centralized only in a few players, the ethics problem will get bigger, because it will not just be an ethical issue about whether AIs have certain powers or rights or abilities and who uses them. It will also be tied to the company's identities that own those AIs. And that whole thing will be much more complicated.
So we face a complicated future, but probably a very interesting one.
Probably a very interesting one. Yes, that's right.
So thank you so much for the interview, and thank you so much for all these moments. And I hope to see you again and shortly.
Yes,
Thank you.
likewise. Pleasure. Thank you for the invitation.